Hey guys, today I want to showcase a project I've been working on. It's a distributed key value storage, basically a caching layer that can be used to store some data outside of your main service. It's written in Golang. It uses a connect RPC client, which is basically just a wrapper around the gRPC, and protocol buffers as a communication schema. It also has some write-ahead functionality to store your data on a disk and recover them if your node goes down and then you need to restart it. I also have an extensive README here with the flow diagrams and some other information about the way that the service is working. But let's dive deep into the architecture here so we can actually understand what this project is about, and then I'll run a quick demo after it so we can see it in action. So basically what this service is a master node that is accompanied by a list of slave nodes. The way it works is you send a read or write request to this service via the TCP using the connect RPC client, which is basically just a gRPC wrapper. The request that you have sent is being worked on in the compute layer. Then it goes to the storage layer. Then the data is stored inside the in-memory database, and then this record is put on the write-ahead log, which basically saves it on a disk. And once this functionality is complete, you basically sync it with the slave nodes, which do the same operations there, really. They just apply the records that have been sent to them via different batches in the storage. They save them inside their own memory databases. They write to their own write-ahead log. And basically that's the way that the communication between the master node and the slave node is being done. Let's run a quick demo. The demo itself will be presented on an application that I've also developed, and it would be really easy to showcase this cache functionality there. So what we can see when the server has started, it tried to recover the data from the write-ahead logs, but because the logs weren't there, the recovery is null, and we basically just started nodes. On each node has its own port, and we're trying to sync with the slaves according to some interval. But let's see the demo. The demo itself is done on a chat application. I'm gonna log in there using the web OS N, and we can see behind this notification that we can see the record of your login timestamp. This login timestamp has been delivered from the cache service, and that's the way it works. So basically, when you have logged in, another service has sent a request to this cache. It set this login record here with the user UUID. It replicated this record to a slave with some additional data here. The slaves have responded because we're running a setup with two slaves here. They have responded that they're replicating this data onto their own databases, their own write-ahead logs. We can see some confirmations here. And when the frontend has sent a request, which is based on some short pooling strategy here, we have received the login timestamp here, and we can see the confirmation of this because we can see this operation get log here, which basically shows us that the record that we have previously set in the database has been found, and it returned some data that was written previously. We can see that the write-ahead logs have been created for each of the nodes that we had. Let's take a look at this. It basically just contains some binary data for us to see. We can see the actual record here and the timestamp of the login. So let's see another example just so we understand it a little better. We can create a chat here we'll call it a new chat, I think. Then we'll send a message, hi there. We can see that the message has been received. We can see a couple more logs here. Basically, they work just the same way. We can see the set for the last message. We can also see the logs for the join room. So that's what we see in the logs here. And then let's do something different. Let's put an end to this service. We can see that the logs have disappeared because the request that we have sent returned nothing. And the reason why it's nothing, because the service isn't available, right? And what we can do now is we can restart the service. We can see that the nodes here started to recover the data that they had in their own write-ahead logs. We can see the log in the join room and the last message records here. We can see that the recovery has basically like initialized, because once you recover the records from your logs, you also need to write them into the database, and that's what happens here. So yeah, each node recovers their own set of data, and we can see that we're listening to the ports here. And then we continue with the normal operation. We basically sync the data with the slave here. And what we can see on the front end is we received the same data there, the data that once was lost, but then was recovered from the files that were stored on a disk. So yeah, I think we can leave this service to run, and we can take a look at the architecture a little better, and maybe see some more details about the way that the project is working. So at the start, at the root, we have this config YAML. This server basically is set up to work on any environment, because we're using the zeros here as the host, and this service is actually with the same config is deployed to fly.io, which is like a cloud hosting solution, and it works there. So yeah, what you can see here is you have your server port and host, your database config here, which has a max size, which is basically a count of records that could be stored in your in-memory database. Then you have the garbage collector interval, which basically clears your in-memory database here. But we can see that it doesn't just like flush all your database, it has some built-in logic there. Then we have the write-ahead log functionality and config here. We can see that we can set the directory and the sync interval. The sync interval for the write-ahead log is basically the time that it takes for the buffered writer that we're using to store the data, basically to store the record in memory to be synced with the file. So basically it's an interval that the buffer data is being put in the file on your disk. The 100 milliseconds here is considered a like medium-sized latency, medium-sized delay, and it provides a nice balance for like input-output operations and being able to sync the data and not let your buffer grow too much. We see the slave addresses, which is basically just a list of slaves that this master knows about. The sync interval, which is a time limit that the master will be synced with its slaves. And the batch size, which is just a limit and a batch limit for the records that it uses to sync with the slave. So basically, no matter how many records you have, they will be split in batches of 100 entries, and then they will be synced with the slave with like separate requests. All right, so I'm using Viper to parse this config YAML. It's a nice library that provides you an ability to set the default values for your services, and also has a nice function to validate your config with like different errors in case something is wrong there. Then we have our package main, which is basically an entrance to our application, and it basically has just two features. It loads the config, validates it, and creates node for each of the nodes that we want to have in our service. So what it does is it goes in a loop over the slave addresses, and it creates a node of a slave, and it creates a node for the master server. The create node itself is basically responsible for two things as well. It initializes the components for each of the server, and it is responsible for the graceful shutdown here, which is basically just a default graceful shutdown config here. Let's take a look at the init components function here, which, as we can see, is set up to work with both the master and the slave, which provides just a nice strategy pattern here for us to initialize the servers. Each of the nodes has its own val, the write-ahead log, in-memory database, a server, and a gRPC client. Basically the Connect RPC client, but it doesn't really matter. Let's take a look at the write-ahead log service here. When we create the write-ahead log, we create the folder for this log, and we open a new file, which is basically just creating a file according to some instructions that it has in the file name, the file path, handles the error, sets the some config for this write-ahead log struct instance that we have. Basically, the important thing here is the last sync, which is a property that we will use to compare when to sync the data in the write-ahead log itself. It has a couple methods that we can use. The append entry, which is basically used to just add a new entry to the log file with some built-in logic there. The sync function, which is basically responsible for flushing and syncing to the file. And flush, as we can see, is basically saving the buffer data, and then this saved buffer data is being synced to the file that we have opened at the moment, the file that we saw there in the open new log file function. Then a couple methods that are basically just used inside the service, the flush and the close, which basically do these kind of stuffs. Then we have the recovery, which is responsible for accessing the write-ahead log files according to some config again. And then this recovery function, it basically gathers the files that it has found and tries to recover the entries from those files and appends them and returns them. And the recover from file function itself is basically just parsing the log file that it has found, which was passed to this function. And what it does is it basically reads the entries from the file. Let me see. Yeah, so basically it reads the file itself. It tries to find the data here. It unmarshals the data that it has read in the binary, and it tries to cast it to a struct of log entry. And log entry is basically a struct that we use everywhere in this application, because that's something that each record has. Basically, it's a object that each record has to be casted to. And we also have the get entry since, which is an external API here. And this function is essentially responsible for gathering the entries that could be restored from the file, and it returns them for the in-memory database to be applied into. This basically concludes this with the write-ahead log here. We can see the database module now, which is it creates a new database instance, and it also initiates the start garbage collector in a separate Go routine here. And let's take a look at the garbage collector here, which basically runs a garbage collector on an interval that we have configured previously in the config.yaml. And the garbage collector here, what it basically does is it looks at the in-memory database, and then it sees if any of the records have been expired, because we have the time to live for each of the records that we store, and it basically just removes that key and updates the size of the database, so we can keep track of the records that are present in our database. Let's take a look at some other methods here. We can see the get method, which is self-explanatory, I think. It just tries to find the record inside the in-memory database using the key that it accepts. A set method with the key and value, and also the time to live, which is meant as a expiration logic here. What it does is it just basically sets this record, this entry record to the database here, and it also updates the size of the database. And then what's interesting is because we have a limit for our in-memory database, we basically see if the size of the database, once it was changed here after our last addition, if it's equal to the max size. We could have used larger than, but it doesn't really matter. And we can see that we call for the evict expired or less function here, which does pretty much the same as the garbage collector, but it also keeps track of the last item that was added to the database. So if all the records that are present in our database have not expired, and we still want to add new records here to basically just update our cache, we can see that we have a logic here that basically lets us remove the last record that was added, like the first. Basically, it utilizes the first in, first out approach here. And we also have the delete function. The delete itself isn't really meant as an external API. It's just used inside this module, and it's used to basically delete the records from the database, so we can keep it within the limits that we initially configured. I also have to say that I'm using the sync map here, which is an alternative to a basic map in Golang. And the reason why I chose the sync map here is because it's essentially a cache solution, and one of two applicable approaches for sync map is if you use it for a cache that only grows. So our cache doesn't really only grow because we still need to keep it within some limits, but because it's still a cache that isn't really meant to be rewritten, we can see that this sync map is actually nice for us because it provides baked-in mutex logic here, and we don't need to handle it manually. The second applicable use is when this sync map is being accessed by multiple goroutines, but because we don't really set read our database in a goroutine, it's basically just a synchronous operation here, and each database is placed inside its own node. This isn't really our case here, but it's nice that it could also be worked in a multiple separate goroutines case scenario as well. The next module that I want to talk about is actually the server, which is kind of different for the slave and the master, but they're also kind of the same. Basically, this is just a controller for our node. And what it does is it just for master it creates the replication itself, and it adds the slaves to this replication, and also runs a recovery that we have previously seen, so we can put all the records that were available in the log files to the in-memory database for this for that quick access from the memory. Let's take a look at the new master replication here, which is essentially just creating a controller for our service, which allows us to add new slaves. It has a logger that we have configured previously. By the way, I'm using a slogger, which is kind of nice and easy to configure. We also have the remove slave. I'm not really using removals right now, but it's nice that we basically allow this to happen asynchronously, so we can basically manage our nodes asynchronously. And also what it does when we create the replication itself is we launch a sync loop in a Go routine. And this sync loop, what it does is it basically just starts an interval, and on each tick of the interval, we run the sync all slaves. And sync all slaves, what it basically does is it gets all the records from the write-ahead log. It combines them in batches that we have talked about previously, and it sends all these batches to slaves, to each corresponding slave, of course. And yeah, the send batch to slave is basically just responsible for that. It creates the request to a gRPC server that each slave node is running. It accepts this batch, casts it to a log entry struct here, and it basically just sends the request via the replicate API, which is like just a connect RPC method there. We also have the replicate entry method here, which is used as a singular replication API here, which is, I mean, it could have been avoided. I could have just used the sync and sync the data with the slaves on an interval, and that's it. But I just wanted to have a solution and a function to replicate data synchronously and basically like instantly, and not wait for the sync interval to happen. But this is completely optional, I think. All right. Let's now take a look at the slave replication here, which is much simpler. It has the replicate method that we have seen previously in the master, and what it does is it basically just goes over the a slice of entries here, which is the batch that we have sent previously, and it just applies it to its own write-ahead log and its own in-memory database, and that's basically it. So slaves are really dumb here. They just accept a batch of records and put them onto its own in-memory database and the log. All right, so what's next for us? Yeah, the controller has the get and a set here, which are pretty much self-explanatory. These are just like APIs for the connect RPC here. You can use those to basically do whatever it says, the set and the get of your records for the in-memory database. Also the delete, which isn't really used right now, but and I'm not actually sure if I'm gonna use it, but I kind of wanted to have an option to delete as well from the outside, but again, like this isn't really used right now. And the replicate itself, which is just an API that is meant to be called for a record to be replicated onto the slave. All right, and the next and basically the last module here is the HTTP server, the connect RPC client, and the server that we initialize right here. So basically what it uses is the server that we have created previously, the master or the slave node. And then we have some basic course config and initializer for the HTTP server here. And what we do here is we have a run function, which is basically solely responsible for the listen and serve here. And we also have the stop for the graceful shutdown. And what it does is it just basically stops the HTTP server on with a timeout here. And I think this actually concludes the this project structure here. The nodes are in there. I mean the logs are in there. We have seen a quick demo with this chat application. As you can see, the data is still available there. Yeah, I think that's it. Thank you guys. Bye bye.